Let's move on to the switch statement. So switch statement is a very common way of simplifying your if and else control statement. If and else can be converted into switch and vice versa, which means switch case can also be converted into if. Switch, on the other hand, is a lot simpler than if and else, especially when you have a whole bunch of if and else nested loops. You can use a switch case to represent majority of that form. This is one example. Switch takes on an integral value check. This integral value checks either this, etc. And the flow of control goes like this. When this enumerated value is checked against case 1 and case 2, depending on what this value is, if this is C1, you'll go into this block. And notice there is a break in between the two cases. This signifies the flow of control to exit your switch when done. This statement, of course, is a combination of several of them. It doesn't have to be one of them. There could be 2 lines, 3 lines, 4 lines. It could also be a function call. Nonetheless, when you're done, this break keyword breaks the entire flow of control out of this switch. If you don't have this break, then what's going to happen is your flow of control, after done evaluating your statement, it'll go into the next case. And if there's no break, it'll go into the next case, so on and so forth. So you can create this cascading effect of logical statements being evaluated several times. They're all different logical statements. One example is this. If, let's say, this E is day of week, then your case number 1 could be Monday, M. Your case number 2 could be Tuesday. Case number 3 could be Wednesday, so on and so forth. And you want your sprinkler to water your lawn on every Monday, Tuesday, and Wednesday, then you could have statement inside each of these dates, but without breaks in between, which means your lawn continues to get water Monday, Tuesday, and Wednesday. But maybe there are some special biological treatment like lawn food or pesticides that you want to spray on certain days. You can add those logic in each of those. Nonetheless, this creates a continuous flow of control where each logical partition gets special logical treatment via this switch case. And you can break the entire sprinkler control at the end of Wednesday. And Thursday, Friday, Saturday, and Sunday would have different treatment plans. Notice there is a default section. This is the same as the else we saw in the conditional statement if and else. Default serves as a guardrail, meaning if none of these cases meets the value of your enumerated E, your flow of control will then directly hit this default section with some statement inside and break. Given that default is always at the end of your switch case, you don't necessarily have to have the break, because once the statement is evaluated, there's nothing else after this. Your control will go out of this switch case and you're done. So this is kind of redundant. But the reason why we like to have break is for continuity, for the sake of readability and consistency. But otherwise, this break serves no purpose. Let's look at another control statement called while loop. This is very similar to the for loop we saw earlier. The general form of your while statement starts with the conditional statement and your statement. There's going to be block in between the statements. This conditional expression is the same as the if conditional you see in there. Let's look at some example. This is a very simple example of a function with a while loop sitting inside of it. Whatever this function is for, it takes an integer parameter starting with the summation equals 0. This is to be returned at the very end. By the way, you don't need to have this parentheses. Starting with if n is greater than 0, then for every iteration, you would divide n by the factor of 10. Meaning if n is 100, after the end of the first iteration, you would have n divided by 10 equals 10. N will be 10. The second iteration will be 10 divided by 10, which means n will be 1. So they're reduced by a factor of 10. That's what this is. At the same time, you have this evaluation. Ordered precedence says that this would take precedence, meaning evaluate it first, and then you would add everything to the sum. N mod 10, depending on what your n is. If n is not a multiple of 10, then this simply returns your remainder. In other words, if n is 109, n mod 10 is going to give you 9, because 9 is the remainder of that. Another way of writing this in grade school is to do this. You get 10 out of this, 100, and then 9. This is the mod, simple. That gives you the remainder. In summation, starting with 0 plus equals, this means sum equals sum plus whatever this is, which is 9. You'll end up with summation equals 9 in the first iteration. And then you just keep on going and going. As you probably surmised already, this example looks like it's trying to add up the sum of each digit of whatever n is. So sum will be 1 plus 0 plus 9 equals 10, something like that. If n is 1, 2, 3, then sum is 1 plus 2 plus 3 equals 6. Check to see if that's the case. Let's move on. This is another use case involving the use of while loop. And note that we have this macro, true. This while loop basically is an infinite loop that runs forever. So this is a very dangerous while loop. You need to have a base condition that checks for the conditions something that will ensure this break would exit. The sentinel value is simply just a value that you define, checking to see what its value is. And it looks like this value is coming from this get integer. Now, the risk involved in having this type of statement is, what if your get integer function does not return 0 that matches the value of sentinel? Then your entire while loop is going to go on and on. And that if, that question mark there, is the risk we're talking about here. This is a quick illustration of a while loop that involves a condition that is not an expression, but a Boolean. Again, this is not recommended way of writing things because you'll end up with infinite loop in some of the edge cases. Let's look at the last example of a while loop. You have the same while loop that goes through this entire block of code indefinitely, and it goes to infinity until some of these conditions meet. As stated before, when you put everything inside the if, else, it's a problem space consisting of this pipe where each of the possible alternatives to consider, you would use a catch-all else to capture the remaining. So this entire problem space is covered with if and else. And you want to make sure that at the end, regardless whether you have the break here or there, you want your flow control to exit this entire loop. Otherwise, you'll continue to run this program to its infinity. At some point, your computer is going to run out of memory or your computer will freeze. Notice your while loop has these curly braces. Another alternative of writing this is having a do while loop. That one does have a semicolon at the end. That is the only difference between do while and while, aside from the iteration for the very first do without checking the while.